Hi friends, we studied analytic functions and CR equations, Cauchy-Riemann equations some time ago, and we solved some problems also. We saw that a function of f of z, the function of z, which is defined to be u of xy plus iv of xy. And if you remember, I also said that u and v are called the conjugate functions of each other when we studied analytic function. Okay, today what we are going to do is that I will show you some couple of quick methods of solving some particular problems. So in entrance exams, there are some problems like you are given u and you are asked to find v, or vice versa. So you are given one conjugate function and you are asked to find the other one. Of course, this can be solved using CR equations, and we have done that also, but here is the quick trick or a relation you can use immediately and just plug in the values and find out the answer. So that is what we are going to see. And another type of questions which are generally asked is that you are given one of these conjugate functions and you are asked to find the analytic function itself. Now this kind of problem can also be solved using CR equations. Like, let's say if I am given u and I am asked to find f of z. So you will say that if I am given u, then using CR equations I will find v, and I will just plug in the values of u and v in this relation, in this way, and that is just the resultant answer is just this f of z. That is true, and that will also give us the correct answer, of course, but that will be a little bit lengthier process. So there is some quick methods that we can use and get the answer quickly. So they are also using, solving these problems using CR equations are definitely correct, but these are just quick methods. So these couple of methods we will see. First we will see how to solve the conjugate function problems. So method of finding conjugate function. So we will see the first case in which you are given u and you are asked to find v. So you have f of z in the form of u plus iv, and u is known. Okay, so v can be found just by using this relation del u by del y dx plus this is minus, okay, minus del u by del y dx plus del u by del x dy. So since you are given u, you can find the derivative of u with respect to y and x, plug in the values here and integrate this with respect to x and this with respect to y, and do the calculation and you will just get v. Now this is derived using CR relation only, and I can show you just to give you an idea, but that is not of much importance. This is the important result we should remember. But of course, because this is a little or a short derivation, we can go through it so that in case we forget this relation, we can derive it even in the exam. So v, since v is a function of x and y, I can find dv like del v by del x dx plus del v by del y dy. Okay, and using CR relations, we know that del v by del x, so our CR relations are CR equations, they are del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. So in place of del v by del x, I can write minus del u by del y. Okay, so this will be minus del u by del y dx, and in place of del v by del y, I can put the value of it. So I can write this as del u by del x dx, dy. Okay, so this is dv. Now if I want to find v, then I will just integrate on both the sides. So v is nothing but the integration of dv equals integration of the first term and the final term, the last term. Okay, so this is itself is this result. So if we know this relation, and if we remember, of course, then we just quickly plug in these derivatives. And sometimes if u is very simple function, you can even don't, means if you have a good practice of finding derivations, then you can, without doing calculation, you can guess the derivative and plug in the values. If the u is simple function, then we can even directly put the values and just integrate it. So if we know this, then calculations become faster and we get the answers quickly. So this is something we should try to remember. In case we have any doubt, we can derive it quickly also. So, and then the case 2 is that we have the same form of f of z, but this time we are given v. So v is known, and derivation can be done like this, but we will just remember the result. So in case v is known and you are asked to find u, then you will do like del v by del y dx minus del v by del x dy. You can derive this also like I did for this case. So by just using these two equations, we can find v or u. Okay, so this is the first quick method. And now the second method which we are going to see, that what if you are given a conjugate function, means you are given a function u and you are directly asked to find the analytic function itself. You can, as I said, of course you can go through CR relation, that first find the other conjugate function and then add them up and then you find the resultant one, or else you can go through some short quick method which is called Milne-Thomson method. This method is used to find analytic function if either u or v is given. So if you are given u, you can directly find the analytic function, means you can directly find the f of z, or if you are given v, then also you can directly find f of z using Milne-Thomson method. So we'll see the first case when u is given. So when u is given and you are asked to find analytic function f of z, then the first step you are going to follow is that first find both the derivatives, because u is a function of x, y. So you find both the derivatives, del u by del x and del u by del y. Call the first one to be phi 1 of xy and second one to be phi 2 of xy. Second step is replace the x by z in the phi1 function and phi2, this one, so we will replace the x by z and oh, I'm sorry, I forgot one more thing. Replace the x by z and y by 0. So in place of x you will write z and in place of y you will write 0. So what do we get? We get phi 1 instead of xy. This time we will find, because we have replaced the x and y by z and 0 respectively. Now we will get phi 1 z0 and phi 2 z0. So replace x and y to get this phi 1 z0 and phi 2 z0. Once you are done, the final step is find f of z equals phi 1 z0 minus I phi 2 z0 dz plus c, and that is it. You just plug in the phi 1 phi 2 values and you will get f of z. Now I'm sure you might think that it doesn't look like a quicker method. Instead there are 3 steps to be followed, but believe me, you find it lengthier right now because you are seeing it for the first time, or maybe you are trying to understand it. But once you get the practice, once you are comfortable with this method, it is really very quick and easy to solve. It doesn't look like too much lengthy because we are seeing them step by step. It seems to be lengthy, but it is very quicker. You can try it. You try and solve some problems, and you will see that definitely this is a quicker one. In second case, when v is given and you are asked to find the analytic function, then what will you do? We will follow the similar process, just the symbols are different to distinguish between u and v. So when v is given, the first step is very same, that first find del v by del x and del v by del y. But I will call, instead of, so here I call it phi 1, here I will call it psi 2. The first derivative is psi 2 and the second one is psi 1. Just this is the only difference, and phi and psi are just used to distinguish between the function of u and v. So here we are using phi's and here we are using psi's, but the derivative with respect to x we call phi 1 and this one phi 2. Here it is just the other way around, psi 2 and psi 1. Second is the same one, the same step, where yes, it is just the same, that replace x by z and y by 0 in psi 1 xy and psi 2 xy to get psi 1 z0 and psi 2 z0. And the final step is find, it is also similar but it will be little bit modified than this one. So f of z will be integration of, now you see, psi 1 of z0 plus I psi 2 of z0 dz plus c. So here you had a minus sign, here you have a plus sign. So this is the only difference, the plus minus difference, and here we call it phi 1 phi 2, here we call it as psi 2 psi 1. That is it. So this is how you can find the analytic function directly using just one of the conjugate functions. Okay, thank you.